In the previous lesson, we looked at exponential functions. Now we are going to look at logarithmic functions, their graphs, and how they're tied to exponential functions, how those two types of functions are related to one another. The first part of this section, I give you a little history about where logarithms come from. This was used before calculators were around. The gist of it is you are given a log table, which are different logarithms, and instead of multiplying large numbers together, you added smaller decimals and then moved your decimal point over however many places you need based off of your original exponents. So in this example, I had 10 to the 8th, so I'd move my decimal point over 8 places in order to get the large number. Interesting way to look at it, but that's a historical perspective. Not really what we use logs for today. Today we use logs more for modeling situations, and that's what we're going to be looking at later in this chapter in our application section. But for today, we just want to look at logarithmic functions, what they are, and how we work with them. So the definition of a logarithmic function is that logarithms and exponents are inverses of each other. So exponents and logs are inverses. That's the first thing you need to know. And once I know they're inverses, I can set up a relationship between the two of them. Y is equal to log base b of x is the exact same thing as me saying b to the y is equal to x. Really, all a logarithm is an exponent. Here the expression log base b of x simplifies down to y, and I see if I convert that to exponential form, y is the exponent. So this expression log base b of x is just what the exponent would be if I was writing in exponential form. The b, which stands for the base, is the same base in both exponential and log form as well. So the first skill that we've got at the bottom here is we want to simplify these log functions. Log base 2 of 32 and log base 10 of 1/100th. The easiest way to do this is to convert to exponential form. So log base 2 of 32, we'll set that equal to x. And I want to solve this expression. So let's convert to exponential form. I know that the base of my log, which here is base 2, is the same base as my exponential form. And the answer to my log is the exponent in exponential form. So this is 2 to the x is equal to 32, and a lot of you could see that this is going to be 5. 2 raised to the 5th is equal to 32. But the perspective we want to look at is how can I convert 32 in terms of base 2? It's that 32 is 2 to the 5th, and when I see I've got the same base, I can say the exponents are going to be equal, which is x is equal to 5. Although for this one you can do that without that extra step, practice that extra step because there'll be some situations where we have fractions or decimals and it's a lot easier to find a common base than do the work in your head. The second example, log base 10 of 1/100th is equal to x. We will once again set this up as an exponential. The base is the same as our exponential. The answer to a log is the exponent, and that's equal to 1/100th. You might know that as being -2 just because they're powers of 10. But if you didn't know that x is going to equal -2, the way you would solve that is you would rewrite this in terms of base 10. 100 is 10 squared. And using your rules of exponents, let's bring this denominator piece up to the numerator. So then 10 to the x is equal to 10 to the -2. So then x is equal to -2.